Hi everyone, we're going to discuss the gas constant lab today in this pre-lab video. The purpose of this is to determine the universal gas constant R, the value of that experimentally. Of course, you're given this value in lecture and in our discussion of the gas laws, and that value is 0.08206 liter atmosphere per mole Kelvin. But what we're going to do here is actually determine the value of R experimentally by collecting a gas and actually determining the values of pressure, volume, temperature, and number of moles, and then from there calculating the value of R just by rearranging that ideal gas equation to give us R equals P times V over N times T. So the way we're going to do this is illustrated as follows. We're going to start with sanding a small piece of magnesium metal. That's the metal that we would use to react to produce our gas. You should ask your instructor for the correct length of the metal to make sure that you don't use too much of it. And what we're going to do is produce hydrogen gas using the following reaction. We're going to mix that metal with HCl, and that reaction is going to produce H2 gas. And we're going to do this in a container that's called a eudiometer, which look very much like, I would say, a burette, which we will use for titration, or if you want to think about it, like a really long and thin graduated cylinder. So there's all these graduations or marks on them, which helps us read the volume of gas that's going to be produced. So the way we're going to set this up is the magnesium metal is going to be reacted with HCl, but in order for us to be able to actually measure the volume of the gas that's generated, it has to be reacted in a way where water is being displaced. So as you may remember from one of our previous labs, we've done a collection of a gas over water where the water is being displaced by the gas. It's getting pushed down by the gas as a result of the pressure from the gas. And so we're going to do something very similar here. We have our metal, magnesium, and the magnesium here is wrapped around by copper, which doesn't react with HCl. The magnesium is just hung there on the side of the eudiometer by the copper wire. And so when the HCl reacts or touches the magnesium, then the reaction will start. Now the way the setup looks is first you're going to pour your HCl into the eudiometer. You're going to follow that by pouring some water into it, again gently through the side of the eudiometer to make sure that the HCl stays at the bottom here because it's more dense. Later on we're going to flip this, and the diffusion of the HCl, which is the mixing of the HCl through the water and eventually reaching the magnesium, is what's going to cause the reaction to start. But right now we're going to put the magnesium right here at the opening of the eudiometer, and then there's a little stopper that's going to close that eudiometer with a little hole there to allow some of the excess of the water and reactant to flow out. Okay, so what you do is then after you set it up this way, you're going to flip this into a beaker that already has some water in it. As you flip this, as you might imagine, the HCl is going to come down and eventually will reach that magnesium, and gases is going to be generated due to the reaction between magnesium and HCl to produce hydrogen gas. So that hydrogen gas is going to bubble up to the top, and then it's going to push the water out through the rubber stopper, and you're going to have a certain amount of gas in there, and the amount of gas just depends on how much magnesium you have. So once all the magnesium is completely reacted, then you're done with the production of the gas. You want to now transfer this eudiometer that now contains some gas in it into a large container of water. We usually have these buckets that hold a large amount of water, and what you want to do is you want to put your finger here at the bottom of the stopper so no additional liquid will come out. When you transfer this, you will pull this out from the beaker and then transfer it into this other large container. So I'm just going to show you how this looks like. So you can see that here I put my finger inside there in the eudiometer, and basically what I'm doing is taking that, lifting it, and putting it into this large container of water. And my goal here is to equilibrate the pressure of the gas inside the eudiometer to the gas outside of the eudiometer, in other words the atmospheric pressure. And the way I can do that is by making the level of the liquid inside the eudiometer the same as the level of the liquid outside. You may be able to see in this picture right now that the level down here of the water in the eudiometer is lower, right, than the level outside. So So I basically will try to move this eudiometer up and down until the level of the liquid in outside and inside are equal. When they're equal, the pressure of the gas inside the eudiometer is going to equal the pressure of the outside, which of course is the atmospheric pressure. Now, the atmospheric pressure can be read in the lab using a barometer. Your instructor will show you how to do this, or that he or she might actually give you a value of the barometric pressure. Now, here's the important part though. The pressure of the gas inside the eudiometer is made up by two gases. There's of course the H2 gas that's being generated, but that's not the only thing there, because we're collecting this over water. Some of the water particles that we have originally also exist in the vapor form. So you need to figure out what is the pressure that comes strictly from the hydrogen gas. To calculate that pressure of hydrogen gas, you're going to have to subtract the atmospheric pressure value with the value of the pressure of the water that's in the vapor state. Okay, so the pressure of the hydrogen gas would be atmospheric pressure minus the vapor pressure of water. The vapor pressure of water you can find using a table that's given in your lab procedure, and there's a temperature and pressure table. So the temperature of the water is measured by just sticking a thermometer into your bucket of water and determining what the temperature is, and whatever that temperature is, you're going to see the vapor pressure of water. So all you need to do is just subtract that to get the actual pressure of the hydrogen gas. Once you get that, you can go ahead and get the value of volume as well just by reading the value on the eudiometer itself, right? Because remember, it's the same as a graduate cylinder, so you can just read what the value of the volume of the gas is. And then you can calculate the number of moles of the gas using stoichiometry of the reaction that we use to generate the gas. And then lastly, for this particular lab, you're going to repeat this experiment a second time in order to be able to get an average of the values of the R that you calculate at the end. So I'm going to show a quick example here on how to do this, assuming that you obtain all the data that I just told you. So let's say you use 0.021 grams of magnesium to generate your gas. At the end of the gas collection, once you transfer it into that container, you found that the volume is 24.45 milliliters measured using the eudiometer. And then the temperature, which you can measure in the water by a thermometer, is 19.5 degrees Celsius. And then the atmospheric pressure given by the barometer is 758.5, and then there's the temperature of the water, which again gives you the vapor pressure of the water. Now, how do I get that 17.5? Just by looking at this table right here. So if the temperature is 19.5 degrees Celsius, I round it to 20, and that will give me a 17.5 millimeters of mercury. Now, some instructor might ask you to take an average of the value between 19 and 20 and get 17 instead here. That's fine as well. All right, so the question is, if you have all these data, how do you calculate the value of R? Well, remember that going back to the original equation, R is calculated by taking PV over NT. So I need to get all these four parameters, PV and NT. So the first thing we start with is just calculating the pressure of H2. And as we talked about earlier, you're going to need to subtract the atmospheric pressure from the vapor pressure of water, which is given right here. And what I will want to do also is to convert that to the unit of ATM, because in the end my unit of R is expressed in ATM, so it'll be 9.975 ATM. I underlined this digit 5 here because that's where the significant figure would end up being. And then the next step is to calculate the number of moles, and this is done by using stoichiometry. So I start with the mass of magnesium that I use, divide that by the molar mass of magnesium, which is given here, and then use the mole-to-mole relationship between magnesium and hydrogen gas in the equation, and that gives me this value right here for the number of moles of H2. The temperature of H2, I can just change the Celsius to the Kelvin temperature by adding 273.15, and that allows me then to calculate my R value. And the volume, of course, is the last step there, but that's a simple one, just converting the milliliter unit to liter. And so here's the PV over NT equation again, and calculating all that gives me 0.094 liter atmosphere per mole Kelvin. Again, some of you might remember that the theoretical value of R is 0.08206, right? It's given right here. And so clearly the experimental value is a little different than the theoretical value, and that's no surprise, you know, because there's several errors that might happen here as we're reading the volume, we're transferring that udiometer to this and trying to make sure the levels are equal and so on. So there's all kinds of error that can come in, and so having a different value of R is really expected, and that's something you should expect in your experiment as well. Now, so that's the reason why we're going to repeat this experiment one more time. Just as you see in your lab report, there's two different columns, trial 1, trial 2, so that you can hopefully in a second time get a different value, and then when you average it out, you get a number that's a little closer to the actual value of R. Okay, and that's pretty much it. Afterwards, you know, you just do your cleanup. The HCl is the only one that you want to be a little careful about when it's concentrated, and so that's the end of that lab.